There may be issues midway. Hopefully there should not be, but there may be. Okay. Are you familiar with? Okay, fine. 2 minutes. I'm waiting. Ayush has posted something.
What were you telling?
No, somebody asked to wait for 2 minutes actually. Nilavrata asked to wait for 2 minutes for a sum. And Ayush posted one more question. A and B with the roots of the equation x square. What is that, by the way? Minus 10x or something else? Ayush? It is 10c, I think.
The 10ax.
Yes, sir, it is 10CX.
And cx, fine. Okay, let's say we just take the Ayush question.
Oh, I saw the next one.
Okay, fine. X square minus 10cx minus 11d equal to 0. And those of C and D with the value of A plus B plus. What do you require? Numerical solution. Answer, Ayush. Otherwise, shouldn't it be the sum of the roots for A. Okay, let's say we have x squared minus.
Is it 121?
What?
121.
I mean, ask him over there. Ayush, what is the answer? Ayush doesn't know, it seems. Okay, no problem. A plus B is given to be. The question is already in the WhatsApp. I'm not writing it down. A plus B is given to be 10C, and A into B is minus 11B. Similarly, C plus B has been given to be plus 10A, and C into D is equal to minus 11B. We require the value of A plus C, B plus C plus D. So that should be 10 into A plus C. How to find A plus C? Well, it should have been 10 times A plus C, but or you could just multiply these two equations. So multiply them out. I mean, the roots are definitely not 0 by the 0 doesn't satisfy them. So we can just cancel out BD to end up getting A into C equal to 120. But the question asked actually A plus B plus C plus D, not A plus B into C plus D. I mean, I should do a mistake over there. I'm getting. I get from here 10 times A plus C. Okay, if I square the first equation.
Sir, you can add the AB plus CD is equal to minus 11B plus D. And sir,
Yes.
then A plus B
Multiply
plus
this
D.
out.
Sir, you can add both the sets, and then we can substitute BD from the first set in the second set.
Well,
plus
actually, you are just saying that we. Okay. What is Ayush? What is the answer? 1210.
Yeah, so it's given 1210, but I don't know how.
So that will be the value of A plus B into C plus D, isn't it?
So wait, let me check the question once again.
If I multiply them out, I am getting. Are they equal? Sum is same as the product. I don't think so. I'm sure there's no mistake in the question.
Yeah, so it's given A plus B plus C plus D. There's no mistake in the question.
No, I'm saying maybe they intended to give A plus B into C plus D. But if it is A plus B plus C plus D, let us see then. At least A plus B into C plus D is indeed turning out to be. Oh, what? Achha, sorry.
Yes, sir. Then A plus B, A plus C into B plus D is equal to 12100.
How come? The product is. Achha, sorry, there's 100 over there. That's fine. That's correct. There's a mistake. I was simply multiplying the zeros over there. Why are you just doing this one over there? I was just simply doing this thing. Yes, A plus C therefore should be same as A into C. That might be a possibility, by the way. Is it? Uh, okay, fine. Let us see. If I add them up, we end up getting AB plus C equal to minus 7 into B plus D. And I could replace it over there. So A plus C into B plus D becomes AB plus CD by 11. Okay, or I might do something else. Multiplying the first equation C, what I get? I get ABC equal to okay. If I add them up, A square, A square plus B square plus twice AB, and C square plus B square equals twice. Very much. We have got addition will give us some value, but D square is not known. Matrix. And I just wait. Let's see. No, that's not working. Look from the folder. So divide them what I get. D by B, so I get A by C equal to D by B multiplier. That doesn't matter much. And then if I divide those equations, nothing happens. It's running in cycles, it seems. If it will find the value of A plus C, that we need actually. So, uh,
Sir, a similar question was given in the KVPY of 2019.
maybe the same question it is.
So in that case, it was 5C and 5A, and that was minus
Oh,
6D and minus 6B.
but it
So,
was similar.
yes, sir.
But right now numbers are a bit different. We have 10 and 11, something to do with that it seems, but cannot figure it out. If I find
So we can find another equation by subtracting A plus B minus C minus D is equal to 10C minus 10A.
that, I don't think is useful here.
Yes, sir. Then we can find
We have
B
just
minus
got
D
from
is equal
here,
to
this relation gives us that maybe you can just put A plus C as some alpha and B plus D as some beta, for example. So we have to simplify. For example, in this case, Hanaki doesn't lead us anywhere, but I don't think it's going to lead us. When this one gives us B plus D equal to 9 times A plus C, actually. That's what relation we have. Now, if I mean, if I just add those two, we still get a relationship between AB, but the B and D are still present. That is trouble we have. We might eliminate it, but in this case, AB plus CD is minus 11 times B plus D, which is nothing but 99 A plus C. But that is not going to be useful, it seems. I get 99. If I divide by, no, not divide by, that won't be useful. I need, maybe somehow I can just.
So we will get another equation by
Hold
putting
on, hold on.
A.
What do you say?
Sir, we will get another equation by putting A in the first equation because it is a root and C in the second equation.
Yes, sir, but I am
Given
trying.
one. Yes, we actually overlooked that fact. We might get something. In fact, what is the question again? A is a root of this equation. So we have A square minus 10 AC minus 11D. Okay, this already is 0. So you get A square and AC. AC is present. No, AC is not present. Secondly, we get in this case C square minus 10 AC. Okay, we could subtract these equations. Yes, we actually get one relation over here, by the way. In fact, that is a good observation. If I look at the original equation which have been given, setting up A in the first equation, minus 10 AC minus 11B equal to 0. and D rather, sorry, 11D for and C. I mean, this is the same thing as if I subtract, no? No, it's not. Minus 10AC minus 11B. So if I subtract them up, we end up getting A square minus C square equal to 11B minus D. That is to say, A minus C into A plus C. But is that leading us somewhere? I do not then terms out of it this way. A plus C we could replace with terms of B plus D, but again A minus C is what? This is just we're going in cycles, we have to do something else. This is not going to be useful. Okay, 9.
So that will be D minus B.
Which one?
No, no. So D minus D. Last step.
Yes, this one. We're going to be D minus B. That's fine. And can you obtain from? No, I think that would have better. Again, this is not. I don't think it's going to lead us anywhere. Just wait. Do something else. You do the other two questions. I'm trying this one. If I somehow can figure out, I mean, A plus C into B plus D, then we may get a required result over there. Why don't we just multiply A plus B into C plus D? In that case, we end up getting what 100 AC. Let's expand it up.
Sir, another equation will be found. Sir, by subtracting the A plus B minus C minus D, then we can get A minus C and B minus D's relations.
Will it give us something? Yeah, yeah, we do have one. There's too many relations by them. Say, it seems that we're just moving in circles. A minus C will become what? Subtract them, so I get. Okay, fine. I'll just at the end kind of reconcile everything. Or maybe subtract this minus this value. So get B minus A plus C minus A equal to 10 A minus C. Take on that side, so I get B minus, sorry, B. B minus B. B minus B equal to 10. This goes on that side, this plus side, which is 11 A minus C is what I have. Okay, so yeah, we could replace it over there.
Done.
Yes, actually, A plus C is turning out to be 121. Yeah, that's fine. A plus C is coming out this way actually. So once you know A plus C, I know B plus D. Yeah, that's fine. This is required. One thing that is not required. Forget about that. In fact, those two things are not required at all. Because once you have got this, adding up and subtracting.
Yes,
and
sir,
then
anything not required. I did not see the question then.
yeah. In this case, we put this D minus B over there in this expression over here. So we get 121 into A minus C. A minus C cancels out, assuming they are not equal. So what is left is A plus C is 121. And therefore B plus D is 9 times 121 actually. So by adding them up, we get the required relation. Yeah, that's fine. This gives us, okay, let us, wait, we start from the beginning. This one is one relation you've got. So now over there we just add these two equations, add and subtract. Add will give us A plus B plus C plus D equal to 10 times A plus C, giving us B plus D equal to 9 into A plus C. And subtracting, we end up getting this minus this. So that gives us D minus B equal to 11 into A minus. And these relations I put in this expression 1. So therefore 1 implies A minus C into A plus C equal to 11 times b minus b, giving us 121 a minus c. I'm assuming that a and c are not equal over there. Obviously, if a and c are equal, then all the roots are the same in fact. This one gives us a plus c as 121. So we know a plus c, therefore b plus d will be 9 into 121. From this equation, and that gives us 1089, and so a plus b plus c plus d will turn out to be the sum of 1089 and 121. That makes it 1210. That's fine. So yes, I guess that is a very good question. Seems we got stuck, but now it is resolved.
So in the second question you gave, we have, is there any other way other than finding the roots?
Yes, there is a way. The second question that I gave.
So it seems there is a way, but I cannot find it.
Yeah, there is. I mean, say you start with factorizing it out.
Yes, sir.
The roots are given, so you can factorize this 4-degree polynomial, and just put instead of x I alpha and minus I alpha, or rather, there's no need. Just put I and minus I, so that'll be enough, I think. Yes, and multiply them out. Get what I said? Repeat, yes. I said for the second question that I posted, where alpha, beta, gamma, delta are the roots. What you do is you start by factorizing it out because the roots are known to us. So you can factorize out the 4-degree polynomial x power 4. What was that? X power 4 plus 4x cubed minus x square plus 7x minus 9 equal to x minus alpha into x minus beta into x minus gamma into x minus delta. That's a factorized version. Now what you could do is, instead of x, you first put x equal to I, and then put x equal to minus I, and then just add them, multiply them out over there. Multiplying them out will actually give us the right side as I plus alpha into I minus alpha, or whatever. I mean, say, yeah, the product will come actually. So you end up getting 1 square plus alpha square, and similar for the other ones. And the left side you can obtain by looking at the product over there. You're okay? Just put x equal to I and minus I in the factorized form and multiply them out. For the second question, that will give us the required result. For the first one, we need a contradiction. Okay. Are you going to say something or what?
Sir, I was saying that in your some handout you have given for quadratic in the group,
Yes.
there, sir, one point was there that it was for finding maximum positive root and maximum negative root by
Maximum
calculating
number
the
of, not maximum, maximum number of.
maximum number of,
Look at the
by
sign
calculating.
changes.
Yes, that can you explain one?
Yes, I will. What I was saying is, if you just want to, if you have a, that will only work with polynomial equation, by the way. Okay. If you take a polynomial, for instance, and consider the sign changes. For example, if I look at the equation which we have been given, the 4-degree equation, x power 4 plus 4x cube minus 6x square
Plus 7x.
Plus 7x minus 9. See, if you look at this equation over there, or better to say, this is, think of this as a polynomial of 4 degrees. Now, that is known as the Descartes rule of sign, actually. It's an old method, Descartes rule of It just tells us the maximum possible number of roots. Actually, it will not tell. It will not exactly give you that it has to be that number of roots, but it can at least give us an upper bound. Okay, what the result says is that if you look at the number of sign changes in fx, this is fx. So if you look at the number of sign changes, that will be the maximum number of positive roots actually. Positive roots. In this case, the moment sign changes. In this case, we have their sign change from plus to minus. There is one sign change. Minus to plus, two sign changes, and then plus to minus, three sign changes. In this case, therefore, we have plus to minus 1, minus to plus 2, and then again plus to minus. The three sign changes. Therefore, the Descartes rule of sign says that consecutive, meaning?
He's saying consecutive
No,
terms.
no, no. That's not required. The sign change need not be consecutive. The sign changes need not be consecutive. In this case, it turns out obviously it becomes plus to minus, then obviously there is, and then again becomes plus, then you have consecutive, but that's not mandatory. It just talks about the number of sign changes. You simply count how many times sign changes of the coefficients from plus to minus. And that will be the maximum.
So how to check then?
How to check that?
So
Look
meaning,
at signs like this, plus minus, plus minus.
can I give another example?
Yes, hold on a moment.
So, but
Let us,
it's you are saying that they should be consecutive.
no, I am not saying. Oh, this is sign. You see, if the sign is like in this case, sign is how what the sign. If I just look at the sign, what I have is plus, plus, plus for this one, plus for this one, minus, plus, and minus. These are signs. So obviously, if there is a sign change from plus to minus, we also have minus to plus, but there is no sign change over there. For example, plus to plus, there is no sign change. In this case, there is sign change from here to here, plus to minus. Then again from minus to plus, again from plus to minus. These need not be consecutive.
Sir, what will happen if if the equation is x to the power 4 minus 4x cube plus 6x?
Okay, but if there was a minus sign over here, for example, say something like we have this one. In that case, we have a sign change from here to here. We had plus, minus, minus, plus, minus. There was sign change over there.
Plus 6x square.
Huh?
So I am telling that what would happen if x to the power 4 minus 4x cube plus 6x square.
Oh, this one.
Yes, sir.
This one.
Yes.
In that case, we have one sign change from here to here, one sign change from there to there, and one from here to here. There is no consecutive required in this case.
No, sir. I am telling that we should check from the highest degree term to lower degree term.
Oh, yeah. Usually, you just go from left to right. It will not matter by the way, but you just take it from left to right actually.
Yes, sir.
Okay. So what it says is that number of sign changes in fx will give us the maximum number of positive roots. That's the maximum number. It may happen that in this case, for example, in the original equation that we had, the sign was this was plus and this was minus. So we find this case that we have one sign change from here to here, one from there to there, and one from there to there. Three sign changes. So the Descartes rule says that there will be at most three positive roots. Okay, three more. It says that it doesn't say that it has to have, but just says that the maximum number of positive roots cannot exceed 4 actually. Sorry, 3 in this case. The number of maximum number of positive roots is going to be equal to the number of sign changes in fx, and similarly, the number of negative roots will be at max equal to the number of sign changes in f of minus x actually. If you look at the expression f of minus x is going to be what? F of minus x in this case. Yeah.
Sir, what if there was x to the power 4 plus 4x cube plus 6x square?
Well, there's only one sign change then from here to here.
Okay, only one then.
Yeah, that's what we have. In this case, it becomes this, for instance. So what it says then is, if you look at the number of sign changes, there is one sign change from here to here. There is only one sign change in this case. So the maximum number of negative root is going to be 1. It cannot have more than one negative root. But it's not a guarantee that it has to have one negative root. That's not requirement. That's not guaranteed thing, okay? But it just talks about the upper limit of the number of positive and negative roots over there. Obviously, in this case, we have at most 3 positive roots, at most 1 negative root. That is what we can have in this case. That is what the sign change says. This is just a rule, by the way. It's technically not a theorem as such. It has been found, okay, there's obviously justification over there. You can look at, but for the moment, you simply look at the rule itself, doesn't matter. It is hardly.
So then there cannot be 4 positive roots for any biquadratic equation.
Well, I didn't say there cannot be. There may be 4 positive roots. You can have x minus 1 into x minus 2, x minus 3, x minus 4.
Sir, but that violates this rule then. Because,
So I said this is giving us a maximum number. If you consider, for example, x minus 1 into x minus 2, x minus 3, x minus 4. It has 4 roots, isn't it? They're all positive. What about the equation? X for 4. Then you have to sum 4, 3, 7, 2, 1, 9, 10 minus 10x cubed. Then I'm going to have plus 2 into 6 into 12 into 8 into 12, whatever. There's a plus thing coming up. Then we shall have a minus coming up, and then we shall have a plus at the end. So there is a sign change. 1 over here, there. I think it is x term will be over here. X term, and there's one constant term present. So in this case, we do have over here number of sign change actually is 4. 1 from here to here, plus to minus, then minus to plus, plus to minus, minus to plus. The 4 sign changes. So it gives us a maximum number of
signs of the terms, not the signs visible.
what? Signs visible?
We have to consider the x to the power 4 also.
Yeah, the coefficients.
Oh, I
What
thought
is-
that we have to.
What is the coefficient over there? 1. It's a positive thing. Look at the coefficients as well. And nevertheless, it is just a rule. I mean, say, it will not give you, it may happen that there are no positive roots. Okay, it may happen. It just, in fact, may happen there are no real roots at all. Okay, for example, we can have x power 4 plus 1 equal to 0. There's no real roots. So it will obviously not work in that case. But the point is, this is going to give us an upper bound. So we are sure, for example, that it cannot be, in this case, for example, we cannot have 4 positive roots. That can be guaranteed over there. In this case, this one. And obviously, it also guarantees there cannot be 2 negative roots in this case. Okay. So that is just saying the upper limit, and that is only talking about the maximum number of positive or negative roots. You cannot rely on this to say that, okay, if this equation has 3 sign changes, it must have 3 positive roots. That's not like so. It is not like that. You cannot say that. Okay, but you could definitely say that because there are only 3 sign changes in f of x, so we cannot have 4 positive roots. That is what I can say. That can be said. Okay, this is what the rule of sign is. It is not a constructive tool that we have over there. It cannot be used to obtain the roots, but it can just tell us what is a bound or number of positive and negative roots. It also doesn't talk about the imaginary roots or the complex roots. It just talks about the positive and negative roots, and that to maximum number. Okay, not exact number of maximum possibility. Okay, Arju? I mean, in some cases, it does become useful, by the way, but I don't think that will be useful for us in any case over there.
Okay, sir, it is okay.
Okay.
Sir, the first question I was thinking that it can be applicable, this rule we can apply.
In the first question that I forwarded today,
Yes, sir.
no, it will not work actually.
So this rule can be used to show that there is no real root. It cannot
This
be used
one?
to show that there is no imaginary roots. Yes, sir, this rule.
No,
Yes, sir, we can. So in case, for example, x to the power 4 plus 1, then we can show that there are maximum 0 positive roots and maximum 0 negative roots, and 0 is not a root.
Yeah, so that just puts an upper bound
Yes, sir.
and only real roots, not complex. It cannot. It says nothing about complex roots over
Yes, sir. We can prove that there are no real roots, but we cannot prove that there is no imaginary roots.
there. No, it cannot. In this question, you have to talk about complex roots. In this case, imaginary actually means complex. It's an old book actually. It's from Holland Knight, old book. So that is why they used imaginary number over there. So technically, a complex number over there. The way that you have to prove it by using contradiction. Anyway, regarding this equation I'm talking about, in the second question, in order to find or in order to prove rather, this was the equation given beta, gamma, delta to be the roots of this equation, which implies that it could be factorized. Leading coefficient just one actually. So actually we could just factorize it out as x minus alpha into x minus beta into x minus gamma into x minus delta, because there's roots over there. So now, because this is an identity, it's true for okay, it's not technically true for all. In fact, for roots as well, it becomes true, and it is true for all other values of x. Technically, in this case, x should have been real, but we can just extend the idea to complex numbers as well. In fact, has to be valid in a complex domain as well, because the roots are in general complex over there. So it has to be a valid expression for every number, every x which may be real or complex. I could therefore plug in this case, for example, x equal to I first put x equal to I. If I do that, this becomes I raised power 4, which is 1. Then I get I raised power 3, which is minus 4i. Then I have got 6, x squared is minus 1, so I get plus 6. And then we get 7i minus 9. This must be I minus alpha into I minus beta into I minus gamma into I minus delta. That is to say, therefore, why you take I? Well, Ryan, what actually I had in mind is basically looking at the right side. If you look at the quantitative figure out, in fact, which was given to be, what was that? It was given to be something like, yes, 1 plus alpha square, 1 plus beta square, 1 plus gamma square, 1 plus delta square. So it was hinting towards modulus of a complex number actually. We could have done this by other means. We could have actually obtained this by a bit lengthy method as well. But in this case, that observation is useful because the form is pretty much like the modulus of a complex number. That is why I'm trying to get the modulus. And one simple way of getting the modulus is to multiply the conjugate number, complex number, which is conjugate itself. So that is why I just took in this case I and minus I by. That's the motivation over there. That's one useful trick that you can actually use in many situations. As we shall see later on, it is going to be very useful putting x equal to some complex number. In many cases, it leads to some very interesting or useful result actually. Okay. In this case, I did that basically because I wanted 1 plus alpha square, 1 plus beta square, and so on. And obviously, there are other ways I can just obtain the entire thing. I mean, say by other means as well. There are lengthy methods as well. Possibly, you can find the roots over there as well. Obviously, it's going to be difficult, 4-degree equation, and there are no nice roots in this case. But that is one possibility that you can have. That in this case, if I therefore, let's see what happens, and then maybe you can just think of this as one addition to your toolbox of solving question over there. Okay, just to put x equal to I minus I, or sometimes, I mean, if you had done the or look at the solutions of the assignments in complex numbers, second assignment actually, I did something like this in one of the questions actually. I just put x equal to I and x equal to minus I, where I had to prove something like there was high n power. I mean, well, there was one question which I did over there. Anyway, this is one useful way that you could always do. I mean, if you know that okay, this is, I mean, say something is valid for. I mean, like if you have been given an identity, say for example, 1 plus x whole raised for n equal to something, then you might, I mean, say, imagine putting x equal to I and minus. In many cases, you have to also put 1 omega and omega square actually. This is a usual trick in many questions that we do. For example, if you have been given that 1 plus x raised power n equal to the expansion a0 plus a1x plus a2x square and so on, and to show that find the value of a0 plus a3 plus f6 and so on, one useful technique is to just put x equal to 1 omega and omega square. That's the usual way that we do, say a standard way. Say it is almost standard now over there. There's useful trick that you can just add to your tool bag. Okay, keep in mind there's going to be one possible way to do sums as well. Just observation is what we need in this case. Okay, so it will be familiar a bit slowly. It obviously cannot be familiar right from the beginning, but we shall. No. I said Nilabrata in the caption I wrote down. In this case, imaginary actually means complex over there. I said it's an old book. That is why they use imaginary term, but technically it's a complex root over there. Okay. Anyway, so in this case, what I get 6 plus 1, 7, minus 9 is minus 2, and then I get plus 3i equal to I minus alpha into I minus beta, I minus gamma. This, and similarly, I can put x equal to minus I because I'm looking for a conjugate. What that means, we have to prove no roots. Why is that, Nilabrata? We just need to show there's no complex roots actually. That equation might have real root, who knows, but no complex root is what I want. The question says
That means purely imaginary. It should not have.
no. I must say there is no such distinction as well, but you see purely
But
imaginary
complex means the
real as
it
well.
is the superset of the real numbers.
You have to prove that in this equation the roots will not have zero imaginary part actually.
Okay, sir. Means purely real. It should.
Means it will be an imaginary part.
Yeah, I mean say all the roots have to be purely real. As the point is.
Sir,
Bolo.
so in the first question there are 8 terms
The first question.
or arbitrary number of terms in that S
Okay.
calculation.
Oh, you take it as a1 plus a1 square and so on. This n terms over there, not 8.
Okay, sir.
Okay. Just mean to say, okay, it just goes on to whatever number you wish.
Yes, sir.
We show that this equation no imaginary roots implies that say all the roots are going to be purely real. That's what you have in this case. That is what you have to prove. And mind you, this is not a polynomial equation, by the way. That is not a polynomial equation. You could check it out. Okay. It could be obviously simplified, but the way it's given, it is strictly speaking, the left hand side is not a polynomial. Okay. Non-elaborate, that is not what I meant. It just meant that, okay, now it's clear, I hope. Anyway, in this case, if I put x equal to minus I, we end up getting what? If I put x equal to minus I, in this case, well, we actually end up getting the conjugate over there. The right side will turn out to be minus I minus alpha, minus I minus beta, minus I minus gamma, minus I minus delta. And this side we end up getting, this will be remaining the same. It will just replace I with minus I. So this will turn out to be effectively minus 3i essentially. So we end up getting in this case minus 2 minus 3i. That will be checked easily. This becomes minus I minus alpha, minus I minus beta, minus I minus gamma, and minus I minus delta. That's we have. So I can just multiply these two equations over there. The first and second equation. This one and this one. Multiply them out. If I multiply them out term by term or pairwise, then I minus alpha into minus I minus alpha is nothing but conjugate to each other. So we get mod of I minus alpha whole square, which is going to give us 1 plus alpha square. So multiplying, we end up getting the required result. Multiplying the two equations, we get 4 plus 9. 4 plus 9 is equal to 1 plus alpha square into 1 plus beta square, 1 plus gamma square into 1 plus delta square. That's what we have. Okay. Screen is
It's a
hazy.
very
Very hazy.
It's okay for me.
Okay.
So today my network is giving dhoka.
Giving dhoka.
Yes, sir, there
Are
was
you
a bit
can I take a
of
picture? Okay,
and
then.
so the Wi-Fi gone.
Okay.
It's done.
Done. Okay, somebody already did that. Fine. Good. I will have to take a picture and good technique. Yeah, this is useful technique. We can actually later on see that.
Second is stand on the side once.
Yeah, yeah. I'm standing on the side, not visible. Is it done?
Yes, sir, done. Yes, sir, done.
Okay, fine. So the answer in this case, therefore, is 9 plus 4, which is turning out to 13. Yes, Ankit, we shall later on utilize this again. I mean, say, even in permutation combination, you'll see that I'll apply this method over there. It's a very useful technique, in fact. Anyway, that is done. What about the first question? Is it done? The first question requires contradiction. First question done.
We can prove that the coefficient of I is 0. Means it cannot be anything other than 0.
You can prove it. Like what?
I mean, if I take z is equal to p plus qi, then q will then there will be a all real part on the right hand side, and there will be a I term on the left hand side. So it cannot be
What?
I
No,
cannot be present.
no, that won't happen.
Okay, sir.
Can you take a picture and send what you've done?
Sir, I thought of that method when you gave the sum, but I then realized that it may not work.
But one thing which is you should always keep in mind is that if you have an equation with real coefficients, if the coefficients are real numbers, in that case, any complex roots will appear in conjugate pairs. That we know, I hope. I mean, if you do have, for example, real coefficients, then any kind of, I mean, or complex roots basically, they'll always
Yes.
appear in conjugate pairs. Okay. If a plus ib is the root, then a minus ib is also going to be root by root. But that only is true if all the coefficients are real numbers. Okay. In a similar fashion, if all the coefficients are integers or rationals, for example.
So does it happen for only quadratic or for
No, it happens
any number?
It is true only for polynomial equations actually, which implies quadratic, cubic, fourth degree, fifth degree, whatever. But it must be polynomial. It will not hold for any other kind of equation actually. Okay, Abhishek.
So the net is lagging. It will be going in sometime.
Acha, no problem. I've got it. Yes, it is. I've got it. So what we have proved that has no even roots. X plus y is a root. So, hey, what have you done? You have taken, acha, you just take instead of x, z, isn't it? Let's take as a sign. Equal to k. Rationalize x minus. And oh, you are
The R
saying,
and P are constants.
yeah, ठीक है. Basically, hmm,
So I've considered that A, small a, capital A, and K are real.
they are given to be real numbers actually. They are given to be real numbers. What is the equation? Is what we're saying. Just wait. See, A seems okay by the way. I'm saying right side is K, which is supposedly a real number. So yeah, that's okay. That's fine. That indicates that we won't have roots which have non-zero real part, imaginary part actually. That's fine. Yes, Shubham. What the method or well, first question again relies on what I said is if you have a polynomial equation with real coefficients, okay. If you have a polynomial equation with real coefficients, all coefficients must be real. In that case, complex roots, if there are any, they appear as conjugate pairs. Okay. So if a plus ib is a root, then a minus ib will also be a root, provided that the coefficients are all real numbers. I was also saying that in a similar fashion, if it happens that the coefficients are rational numbers, if it happens that the coefficients are rational numbers, in that case, the third roots will be appearing as conjugates actually. Like if you know I have an equation with all coefficients rational, okay. In that case, if we end up getting a root like 2 plus root 3, in that case 2 minus root 3 also will be root actually. You're fine. That's what we have in this case. So we can utilize this idea to prove the first question. We can counter, say, in the first case, we can just assume that, let us say, for example, if we do have some roots which are having non-zero imaginary term. Say, for example, let's say that A and B are already used. So let's say P plus IQ is a root. This is for the first question that is sent. So to show that capital A squared by x minus A plus capital B squared by x minus B and so on equal to 0 will equal to k rather will not have any complex roots. So that I'm assuming that P plus IQ is one of the complex roots. Then P minus IQ will also be a root actually. Okay, so what I can do is basically plug these both of them, or it doesn't matter by the way. Can yeah. Well, it maybe possibly we do not need to do this. Or what I might do, for example, is I can just put these two values instead of x. For example, then what I might have is then a square upon, instead of x, I put p plus iq. So I get p minus a plus iq, then b square upon p minus b plus I into q, and so on, dot dot h square by p minus small h plus iq equal to k, and because the conjugate is also a root, so I just replace I with minus I actually. So we also have p minus a minus iq, then plus b square upon p minus b minus iq, and finally h square by p minus h minus iq equal to k. So if I just subtract these two equations, for example, term by term, subtract these two equations. If I just subtract them up, the right side turns out to be 0. And if you look at each of the term, for example, if I consider the first one, I could take the LCM, and subtracting, what I end up getting is a square common. If I take the, it's a difference I get in this case. Look at the first term, this minus this. So we end up getting p minus a minus q minus p minus a minus iq, which implies I get minus twice IQ into A square upon. Denominator become just multiplying these two, but they are actually conjugate, so the product becomes the LCM basically, becomes the modulus square. So I get P minus A whole square plus Q square. Similarly for the other terms, minus twice IQ into B square upon P minus B whole square plus Q square. And finally, minus twice IQ H square upon P minus H whole square plus Q square equal to 0. So now you see in this case that if I just pull out twice IQ common over there, we end up getting the sum of the squares. The sum of the squares cannot be 0 actually, unless until I mean, we obviously assuming that all of ABC they are not 0. So in that case, we end up getting. Is it fine, all of you? I hope picture is not to be taken. No, it seems. Wait. Okay, fine. This is basically it.
Sir,
Yes.
sir, here you are taking two means, one is P plus IQ and one is P minus IQ, but you can also do by only taking P plus IQ. By rationalizing it, you will get
Yes, yes, that
in
I
the
could do.
denominator.
That I could do. I just well, kind of wanted to utilize that idea. That's all. I could have rationalized it definitely. Yes. If I rationalize it, I'll end up getting. Well, in that case, I won't get the right side as 0 by the way. That's what I'm trying to do. If I rationalize it, for example, okay, Ankit, Abhishek did that
Sir,
over there.
right side will be real and here I term will become 0, will should become 0.
Well, if I rationalize, no. There's in that case we might have a problem in the sense that K was not specified as positive by the way. It is real definitely, but everything else will turn out to be. If I rationalize, no. We end up getting. Oh, yes, there is actually a problem with this. My hold on, by the way. Let me check Abhishek method. He has done similar thing what you are saying.
So there will be a x minus a term. So the minus a can be gradient. So it can be positive or negative.
Yes. Okay. A square into x minus a plus b square into x minus b. So this is equal to k. And whatever. Okay, fine. That's fine. Basically, what we are getting for the imaginary term that cannot be at least 0 in its own accord. That can happen over there. Yeah, that's fine. That's fine. Okay. It's okay. It's okay. I mean, say you could have done by simply rationalizing it as well. Okay. I just wanted to utilize this idea over here. You can see in this case, if I look at this one, will actually give us upon taking minus 2 IQ common, we get something which is actually positive. A square by this entire thing, B square entire thing, H square entire thing, all non-negative numbers. So unless and until Q becomes 0, the entire thing cannot be 0 over there. There's a contradiction we have got in this case. Unless until Q becomes 0, we shall not get. This becomes A square by yes, and that is not going to happen, which cannot happen unless Q equal to 0. Okay, which implies that the imaginary part has to be 0. That's fine. Okay, I just remember another question that I had.
Sir,
हाँ बोलो.
sir, I thought of this rationalization method and then equating that zero, but and sum of squares that will not be negative. So then I did a very silly mistake.
What?
Sir, the thought came and it got solved also, but then I thought that one may be p plus iq, the second one may be r plus is, and
Okay.
I
Fine.
thought of all different values for
Different
solving.
values. Yes, yes, I got it. ठीक है, no problem. It's okay. Okay, fine. Should I rub it now? Clear enough?
Yes, sir.
Arjo, what about you? Rubbing it up. Okay. Okay. The next question again, because I remember it's we'll ask it over there. The question is this. Huh?
Should I send this to the group?
Well, we'll finish it up. What else? Before that, you already taken a snapshot, isn't it? Finish it up, yeah. Just take it
Yes,
up,
sir.
take a snap and post it. For whoever reads, there will be continuity over there. We're done. So I hope it is done now. Late. Anyway, next question is again dealing with some polynomials. I might have
Sir,
asked
done.
this. Done? Okay, fine. The question is, yes, Arju, what happened? I have a doubt. Go on. Tell me your doubt. What is your doubt? Meanwhile, I'm rubbing the board. It will take a long time to write. Question it is. You almost talk in poetry, by the way. Yeah, yeah, just go and post it up.
Great potential.
Yeah. Today in the morning, I was talking to a class 12 student actually. And he was also speaking something in a very similar tone. मेरा नहीं हुआ है. मतलब we almost like singing. He was speaking over there. I don't remember the exact full thing, but okay, Arju, you can post it. Go ahead, do that. Meanwhile, I write in the question. Okay, I'll just post it by. Let's see what it is. Which one? There are three of them, by the way. Acha, inequality. What's the trouble with this? You put 3 raised for x as t, you get a quadratic and solve that. What's the trouble with that? You're not getting the answer? Yes, Elabrata, I do speak in Hindi in class 12 batch because they're all comfortable with it. And I'm comfortable with them mostly. No, but he was actually talking over the phone, in fact, when he called. I thought maybe, I mean, it's actually, I don't know. What about you guys? All of you are comfortable in Hindi?
Sir, we have been comfortable in Hindi, English, Urdu, Bengali, etc. etc.
Okay, great.
Yes,
What
sir.
about
Sir, Urdu answer.
Persian? Urdu?
Yes, sir.
That was an exaggeration. Urdu.
Urdu to khair, we know about the songs by there, but Hebrew, no, Hebrew I do not know. I do not know whether you know it or no. Hebrew, or for that matter, I mean, foreign languages I'm not very familiar with.
Talked in.
Yes, sir. It is nice to hear Hindi.
Nice to hear Hindi. I should better go to Philippines. Why Philippines? Right?
So you can go with Hindi also.
No problem. If I feel that people are not able to understand, in that case, I will speak up in Hindi. Don't worry. Last year, you speak. Yes, Ayush, I did. Normally, when you have in a classroom, there'll be a different story. The classroom, when physically present, I can see your expressions. So mostly, I can change or adjust accordingly. Okay, but in this particular mode, I do not know whether your looks are whether you're well. I mean, say you're looking frowned or confused, or I don't know about that. So that is why. Anyway,
Sir, do you picture us as
Sir, as a
boxers?
matter of fact, you don't even know if you're humans or aliens.
no, that I know. I at least have met a couple of Abhishek. No, Abhishek. Ankit came over here once. I know Nilabrata. I know Onik. Arjo. I haven't met him, but at least well, kind of. Ayush, I know. Ayush Raj. I don't know most other people actually. Ryan, I have talked over, but I haven't seen. Suveksha, I've talked over, but Vyasa, I have never talked, I believe. Argadeep, well, many people, Swikat, for example, I haven't seen them ever in picture as well. So, anyway,
So you can ask people to upload pictures of them.
no, I mean, say when people log in, I find that nowadays many people have put up their own pictures actually. Akash, I have seen his picture. Anik, I know of. Abhishek, I don't see a picture. Argadeep,
Sir, because I don't know that much of computers.
oh, no problem.
And it's more
Yes,
hectic.
headache.
Yes.
Arjun always put some flowers over there. Atri doesn't put anything. Atul, I know. Ainak,
The Zoom ID is the best.
what?
So it's like gallium or something like that.
What?
It's
Again?
it's a metal which is liquefying or something like that.
Metal? What is saying?
Metal.
Metal what?
Metal liquefying. It's
Metal liquefying. Oh,
yes, sir.
molten metal.
Sir,
What about
whose?
whose? Yeah, whose?
Yes, sir, Arjos.
Arju's molten metal. I think it's
Yes, sir,
some
sort of
kind of
that.
flowers actually.
No, sir, it is for meat. I'm saying for the Zoom.
But let me see. They are flowers.
Sir, it is for meat. I'm saying for Zoom.
For Zoom, you're saying.
Yes, sir.
Acha, in Zoom, he put some other
Oh,
pictures.
it's a cake. Sorry.
Oh,
Oh, acha.
it's cake.
He's saying cake. He's not putting anything metallic. It's just cake. That's what he's saying. Okay, fine. Let me first write on a question, and then I will solve Arjo's problem. Okay, because that is seemingly a bit easy. Anyway, the question I had in mind is the following. What we have is, let us suppose that f is the polynomial. This is a question from polynomial, technically speaking, but nevertheless, we can deal with this because it involves the idea of roots over there. Of degree, say 11. That is fine. Fx equal to k by k plus 1, or rather f of k rather. F of k is k by k plus 1 for k equal to 0, 1, 2 till 11. So it so happens that fx is a polynomial of degree 11. And it satisfies this condition that f of k is equal to k by k plus 1, but only for these numbers k equal to 0, 1, 2 till 11. I'm not asking to you Pratyush. In that case, you can relax and do our Arjo sum. I might have asked more than 3 times because I have been teaching for a long time. So maybe for every year I ask it over there, isn't it? You are facing it for third time, but I believe other people do not know about that. You just do something else. You just, for example, do Arjo's question and send it over. Okay. So determine f of 12. From where did you get this question? Well, this is mine for a long, long time, by the way. Very early. Nowadays, it has almost become quite common, but the first time I saw it, I don't. Uh, I think there was a book which I bought quite very early. I mean, say almost 5 to 6 years back, I think. The name is The Art of Problem Solving, Art and Craft of Problem Solving, actually. The author is Paul Zitz, in fact. Art and Craft of Problem Solving. At that time, this book I bought quite costly by. This is, I think, the pretty much the costliest book that I have bought. It costed me at that time around 6,000 rupees, in fact. At that time, it was there. Obviously, that is one we have. So in that book, I found it up. But modified form have been in air for a long time over there. No, I'm not talking about art of problem solving. That is not.
Sir?
Arthur Angel is actually uh, problem solving strategies. That's what the Arthur Angel book is. Yes, you are saying something, Sulecha? Or somebody else? Huh.
No, sir, I was not clear.
Oh, who was saying that, right?
Yeah.
I cannot see who is speaking.
Yes,
By
sir.
yes, 9. Yes, yes. What you're saying?
What you have written for K? Can you please read out?
0, 1, 2 till 11. Okay. This is from 0, 1, 2 till 11. For those numbers only, this is being satisfied. It is not an identity actually. Fine. Now regarding Pratyush, are you solving Arjo's question by the way? Good. Solve it and upload in the group either. Okay. Then I need not do that much of work. It's raining quite heavily. Someone said that you gave it the third time. Pratyush. I mean, he actually was with me. I think he came in class 9, isn't it? Pratyush? Yes, he came in class 9, I believe. Yes. Onik was also there. Yeah. It might be. Yeah, might be. Don't remember the time. At least for me, time flies by. It is very difficult to keep track of time. When the regular class was going on, then also, and now also. A month passes by almost like a blink of an eye, effectively. I mean, that's a metaphor of this. So it's not a. Yeah.
That's for us too. Sad reality.
Yes, difficult to keep track of time actually.
So we didn't understand when we got promoted to 11.
I mean, now right now,
Because we didn't complete the exams only.
that is the point.
We
That
thought it
is,
would be exams to be held
So
in
it
May.
generally,
If they didn't get
sir,
held. We
yes.
studied for them, yet no exam.
You are just
And then
hanging
suddenly,
either in class 10 nor in class 11.
yes, so we were hanging
sir,
for
sir, promotion
around
is
2 to 3 months.
You remember, have you heard of the story of a king named Trishanku?
Yes, sir.
You know about
Trishanku, there's Trishanku heaven. There's
Yeah,
a thing.
actually, it is related
Vishwamitra
to King Vishwamitra actually.
Mission.
Vishwamitra was earlier a king.
Great
He
movie.
became a rishi later on. But yes, there was one king who kind of did to, I mean, say he was quite well a good king over there, and basically he was supposed to go to heaven. I mean, Vishwamitra
Oh,
gave
he
him
wanted to go to heaven with his body.
with his body, bodily. Yes, he was supposed to go to heaven bodily, but then other deves they kind of were not happy with this. So there was a war ensued between Vishwamitra and other gods, kind of, and ultimately Shiva himself came possibly to stop Vishwamitra. So Vishwamitra kind of created one different world, a different heaven between the earth and the skies over there. Whose name, Argadeep? I said Trishanku.
Sir,
Huh.
the promotion is generally a discrete process, like suddenly from 9 to 10, 10 to 11, but our happened in a continuous manner.
Fine. So it always takes some time to change things in a real life situation, isn't it? So that is
Took
what
a
you
bit
just.
too much time.
Yeah, at least you didn't feel a shock, by the way. It was not a shock in that case.
The shock we are still in passing. We
Sir,
haven't
I'm
yet
still in
forgotten
shock.
10.
Okay. In any case, now you even your
So
11th will just
because
pass like this, and you were not able to.
so because in
Yes,
normal
happens
times
actually.
we would have visited school for at least 2 3
I know,
times.
I know, I know, I know that. Nothing is normal nowadays. Arjo, what do you want to ask? Question of science rather than maths. You can ask. Okay. Paranormal, no, that will I won't answer about paranormal over there. Yeah, now I'm free. People are doing some, so I can just ask over there.
Sir, you have a box
What?
and you you are having a box, means a wooden box.
Wooden box. Oh,
Yes, and now you are a person and you are pushing it, and
I'm a
you
person.
are yes, and you are pushing it, and it is means kind of it is about the right left means rightmost bottom corner. It is just rotated, and it came means one rotated and it came to ground again.
Okay.
Now means how much work you have done, that is asked.
How much
Means
work I
I
have done?
yes means
Well, I have done some work at least, but the difference is
sir,
going to
I'll
get
say a thing.
what?
Means I have a problem is that the total displacement is not there, and change in means you have not changed the speed also, and potential energy is
Yeah, I
also
did
not
change
changed.
the
So
medium by the way. I did raise it over there. It's another story that when it just came back to the ground, that energy is getting lost because of collision from the ground. Otherwise, I did raise the center of mass from lower to say upper. So I have done some work over there. I mean, it's a
but
difference is
sir,
that it comes to rest only after colliding with the ground. Okay, so that work is lost. But you did definitely have done some work because you see, I have to just kind of if I have this box over here, there's a box like this. You have to just raise it over there and then bring it like this. So what you're doing actually, you're raising the center of mass. I mean, some work, potential increases, then it is stop. In this part, if you just leave it, it will automatically go actually. But yes, if you just bring it slowly if you do it, then you are actually doing something then, and then the total becomes zero. But if you just lift it like this and simply release it to fall, then you have done positive work actually. Okay.
okay sir. Means I was saying that in both the cases I was actually doing the work physically, but while putting it in the equation, it is becoming zero total.
So because you are actually dealing with slightly, you're actually putting in the equation after it had come to rest on the ground. But before that, because before that it actually hits the ground, so there is energy loss over there actually. Okay,
Okay, sir.
fine. What about this? Just wait a moment while I'm coming. How much you getting? 66. What this one are you saying or? I don't remember the answer. I just have to just do it. Let me. I just wait a moment. I will tell you. No, Nilabrata, that is not correct. That is wrong.
Sir, will the answer be within 100?
Oh, yes, definitely. Anik, have you done it? Anybody? I just, the answer is going to be one actually in this case. Yeah, I mean, I was asking whether people have done it or no. Okay, it seems that I will just finish it up. Wait. Okay, I will wait. 3 minutes, 4 minutes, that's all.
So the denominator created the problem. If it was only numerator, then it was easy.
Only numerator, that case becomes a linear polynomial, isn't it? I mean, f of k equal to k, that is, denominator is,
Yeah, like f of k is equal to ax minus b, something like that. Then it would have been easier, but this is complicated.
yeah, in this case it
There
is
has to
not
be
that.
a
Yeah,
specific solution for this sum. I think there is no general solution.
well, what is my general solution?
I mean, mm, something that can be applied to any such type of solution, any such type of sum.
The technique is going to be general. Obviously, it will depend on the degree over here. But I could equally call it as a 100-degree polynomial. But I have changed those numbers as well. You see, in
So
this
that only was telling.
yeah,
There is this type of sum as this type of solution only. Specific solution.
that is true for all equations, by the way. There's you can't apply something generalized to. I mean, obviously, apart from solving the equation, there's solving equation you have a standard way. But apart from there, you don't have much. Okay, Nilabrata, are you okay? Done now so far? No. Pratish, you know the answer in this case. Arju is unable to join. What to do about that, by the way? I'm only seeing the meet is stopped. But weird. Arju is facing a unique problem, it seems. To him, the Google Meet says that the meeting is over. Anyway, do this sum, take up a snapshot, post it, that's all. You see, in this case, the idea or the trick is what? You notice in this case that first of all, the numbers which have given, there are 12 of them. 0, 1, 2 till 11, the 12 numbers in fact. Okay. However, the polynomial is of degree 11, so it can have at most 11 real roots. Fine. You should notice that for any polynomial of degree n, there are exactly n roots, which might not be real all and might not be distinct. And about the real roots, there can be at max n real roots. If we have a polynomial of degree n, the number of real roots can be at max n. Fine. In this case, obviously, fx will have at most 11 real roots. So the numbers are given to 12. But there's one trick that is what you could do by the way. You notice in this case that this one is valid for each of those k. Fine. Let us define a new function. We just define another polynomial. There's a trick in this case which is involved. Define a polynomial gx, which is x plus 1 into fx minus x. Look at this. We define this particular polynomial. G of x equal to x plus 1 fx minus x. I have constructed it from this expression. I just brought this k plus on this side and k on this side. So it is not, I mean, then what we have got is, first of all, this is a 12-degree polynomial, okay, because fx is already 11 degree, and I'm going to multiply with x plus 1, which makes it, this is effectively a 12-degree polynomial. We've got this 12-degree polynomial, and in addition to that, you notice that these numbers 0, 1, 2, 3, and 11 till 11, they actually are roots of this one, because if I put, see, for each of these k, this one is satisfied, which implies this becomes 0. But only for these k, not other numbers, but at least for these numbers which have been given, those 12 of them, 0, 1 till 11. For these numbers, this one will turn out to be 0, which implies that, yes, Ryan, I said that I first of all define this polynomial gx, which is x plus 1 into fx minus x. Okay, this is a polynomial that we have defined. This I have done by looking at the given expression. I have taken this k plus 1 on this side, k on this side as well. And well, you see over here, I just take this k plus 1 over there, so it becomes k plus 1 into f of k, and then k on that side, I get minus k. So k plus 1 into f of k minus k is what I have. So I just converted, instead of k, wrote down x. Okay. So yeah, why is that useful? Because first of all, it now becomes of degree 12 over here. And in addition to that, because this particular relation, you find that these numbers are the roots actually. Because for them, this will turn out to be 0. Not for other, but at least only for these k. Only for these k, it will become 0. For other k, it might not be, but for these k, it becomes 0. So I can say that this becomes, therefore, then due to this given expression over there, 0, 1, 2 till 11 are the roots actually. These are the roots. These are roots of this particular polynomial. And you notice that there are exactly 12 of them. This is a 12-degree polynomial, and we have 12 of these actually, which implies these are all the roots in fact. These are all the roots basically. These are all the roots that we have. Okay. There are no other roots actually, which implies that we could factorize it out. Therefore, it can be factorized. Therefore, we can factorize gx, which is same thing as x plus 1 into fx minus x. We can factorize that. A into x minus 1 into x minus 2 till x minus 11. I was able to factorize this because you know all the roots. I have multiplied with a unknown constant a for because I don't know the constant over there. Leading coefficient is not known to us. So I just multiplied with a, which I need to figure out. But apart from this a, I know all the roots. There are 12 of them. So we know all the roots of this polynomial. And that is why we have just factorized it out. Okay. But if you know the roots of a polynomial, you can factorize it out. Now, in order to find a, what to do? First of all, notice that there is no other information given. We have already exhausted all possible information that has been given to us. So I cannot basically put any other values of x. But we need to find this a. Okay. Now again, to find this a, what I do is I look at this. I look at this expression over there. I find that whatever be the value of fx, if I put x equal to minus 1, if I put x equal to minus 1, irrespective of what f of minus 1 is there, the value of this entire expression turns out to be 0. Okay, so that is what I do. I just put x equal to minus 1. That way, I'll be able to find the constant a actually. So we put x equal to minus 1, and what it gives us is this set x equal to minus 1, in which case this part will turn out to be 0. I do not know if of minus 1, but it doesn't matter. It's going to be something finite because this is a polynomial. So that we end up getting this part to be 0. And we what I get is x equal to minus 1 gives us 1 equal to a into minus 1, minus 2, minus 3 till minus 12. That's what we have. There are 12 product terms in this factors in this product. So 12 times minus 1 becomes plus 1 actually. So that becomes actually 12 factorial into a. And this gives us the value of a as 1 by 12 factorial. There's the value of a. It's 1 by 12 factorial. I hope everybody knows about factorial in this, I would say. So far, I mean, by now, we just know the value of, what is the meaning of factorial in this case. Anyway, that gives us the value of a. So we go back and put it over there. Fine. Just put in this expression. Therefore, we end up getting x plus 1 into fx minus x is 1 by 12 factorial into x minus 1 dot 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 till x minus 11. That's what I've got so far. Now what I can do, because I wanted the value of x f of 12, so now I'll put x equal to 12 in this expression. So put in this case x equal to 12. If I do that, I get 13 into f of 12 minus 12 equal to, what about the right side? I notice that this becomes 12 into 11 into 10 into dot 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 till 1. So again becomes 12 factorial. It becomes 12 factorial by 12 factorial, which is nothing but 1. It turns out to be 1. And that becomes, therefore implies that f of 12 is 1, because 13 f 12 becomes 13. And therefore, we end up getting, okay, but I'm running out of space. This slide. Therefore, I get 13 times f of 12 equal to 13, giving us f of 12 equal to 1. That is the required result there. Is it not visible? Is it visible or no? The last part? It doesn't seem to be visible.
Visible.
Visible. Okay, it is visible. Okay, it was not visible to me. Fine, it is not visible. F12 is therefore equal to 1. Okay, so that is what we have. And that will be all for today, by the way. Maybe I can just give you some more questions like this if you have done that assignment over there. And we should try to move ahead from equations. What should I do? I was thinking of the next topic to be what? Summation of series should we take up? Or combinations, commutation combinations?
Combinations.
Well, you are only speaking, somebody saying series. Okay, let's look at series first because it will be utilized also in permutation combination over there.
The series is a small chapter.
Is it? Fine. In that case, it's okay because we finish in one day in that case.
Yes, sir. HP is there.
I mean, not necessarily. I would like to talk about some general means like the method of differences over there, or the usual or generalized means to. Yes, derivatives definitely. Bye. Okay. We shall just take up first series. Maybe to take a couple of classes. Then we can move over to the permutations and combinations over there. Fine. Because that will lead to the binomial theorem, and then it will be almost towards the end over there. Oh yes. Can you take up a snapshot, Sohar, or anybody else, and post it over there?
Someone sent already, I think.
Is it done?
What is the only sent?
So sent.
Okay. Yeah, I hope that I'm not in the picture. Yeah, it is done.
Sir,
Yes.
if we will have to determine the f of 12, then how will define the equation for 13 degrees? Sorry, if we'll to determine the f of 13.
If you want, if what was, if you're asked to give us, no, if you
If
want
we are asked to determine f of or anything other any other else, then
any
how
other
will
thing,
we find
no
the
problem.
equation for 13 degree?
I mean, say, is this given? I mean, these numbers are given, or something else is given, or you just want to find in this case f of 13 or 14 or 15.
Yes,
In
sir.
this
Yes, sir.
case, then you just put over here. What else?
This case. Yes,
Yeah,
sir.
you just, we have already got enough information. You can put over there. For example, you put say I want the value of f of 100, for example. Then I put it over there. 101 into f of 100 minus 100 equal to becomes 100 into 99 into 98 till 89 possibly, uh, or whatever, and divide by 12 factors. So it will become a big number, but can be found out from here itself. Now it can be obtained from there. Any other value. This will give us all possible values now, because it's going to give us effects over there. Okay.
Yes, sir. Okay, sir.
Okay, fine. Okay, then that will be all for today. Just go have your dinner.
Thank you, sir.
What? Your voice is just going, not coming through actually. Nilabrata, why the question mark? Oh, when you take a binomial, I'll take a binomial after I do permutation combination. Yes, thank you. Ryan, good night. Is it okay, Nilabrata? It will take up a couple of classes, but it will take up some time. And permutation combination will take some time over there. Even if I finish a series in a couple of classes, the permutation combination will take some time. But once you're done with that, the binomial is not going to be taking too long over there. It's going to be rather.
Sir, is there any complicated part in series?
Well, not exactly complicated, but I just wanted to look at the telescoping series, for example, the way that it
Oh,
operates,
yes, sir.
those things, not AP, GP, that I think
No,
everybody.
I thought progressions.
No, no, no. Some useful techniques, that's it. And then we can just move over, okay? Okay, bye all of you then. I'll stop the recording part and finish.
Hi, sir.
Bye.